assignment 3, main assignment video. Before watching this video, please watch the installation or the setup video for assignment 3. Let's start with the task 1. This assignment has the 3 tasks in total. The first one is timeline generation, second one is file recovery, and the third one is related file analysis. So, in timeline generation, first we need to know the sector details of the disk. So we will be using the mmls command. So we use the command mmls followed by the name of the data set that we are using, the dd file. So it gives the partitioning table, and it has two main partitions, both of the type nfts and exFAT. So the partitioning or the sector offset that we are looking for is this one. That's where the first partitioning actually starts. That's 2048. Please do remember this. And now we have the sector details. Now let's start with generating the body files. And we generate this body file because it contains the metadata for timeline analysis. So what it basically does is gather all the metadata from the pc.dt file and then copies it into this file test underscore timeline.body. So if we check it, test underscore timeline.body file is generated, and once that's generated, we can check the content using this command, that is wc -l test timeline.body. It counts the number of lines in the generated code or the body file. So it returned 179. That means 179 lines are there in this file test underscore timeline.body. And next, so out of this total 179 lines in the timeline.body file, we will be generating just the timeline from March 2015. That's when the incident happened in the organization. Here we are using the command mac time because it creates a human readable timeline from the body file that we have previously generated for the specific date range. That's from 1st March 2015 till 31st March 2015, and it stores all this information. This file, that is test underscore filter.txt, and here the parameters d represents the data format output, and b represents we need a specific body file input. We are giving it specific body file input. So now let's check if the file is generated. Please ignore these errors. They usually occur when the file is corrupted. So now the test underscore filter file is generated. We can see the contents in it using the command open followed by the name of the file. So this is the timeline, March 2015 timeline that we need. It has all the file names, the permissions, and also the time when it's accessed. This is all about task 1. Next, let's proceed with the task 2, that is file recovery. So, for this task, we are first generating, or sorry, creating a directory called test underscore recovery. So, we have created the directory test underscore recovery, and after creating the directory, next we use this command tsk recover offset 63 and then flag e followed by the name of the dataset that we use and the folder that we have just created. But here we need to make some changes according to our situation here. So as we have seen it here, our file starts at 2048 and not 63 sector offset. So we need to change that. So I'm changing it from 63 to 2048, and then also and again we are using PC file and not the RM2, so we need to change that. And then you can see 40 files are recovered, and we are using tsk underscore recover because this recovers all allocated files from this image to specified directory. So next we will be checking the files. So first we use this command. So what this command basically says is we need to list the first 20 regular files found in recovery directory. So that's the directory we are giving, and also we are giving how many numbers we need. We can change it to 10, 20, or 30, anything we like. And then you can see the first 20 recovered files here along with the complete address. We have this one. So we are using this command to see the detailed listing of recovered directory contents. You can see all the I would say the subdirectories in the main directory test underscore recovery with the permissions and the dates that we have created. Next task we have is deleted file analysis results. So in this first we will list all the deleted files, and we will be using a tool called foremost which recovers deleted files based on file IDs and photos. So we can install it using the command sudo apt install foremost, and we need to enter password. So now the foremost is installed. Next we use this command foremost underscore I followed by the name of the dataset that we are using, the file that we are using. So what it basically does is recover deleted files based on file signatures, and here the parameter I indicates that we are inputting disk image file, and here the parameter O indicates that we need an output directory for the files that we have recovered. So it might take some time, so I will be pausing the video. So now we have completed transferring all the record files to the directory, output directory, and next we can do the metadata extraction from record files using the tool exif tool. Uh, it's an inbuilt TSK tool that is used to extract important metadata. For the purpose of this assignment, I'm stopping this now. Let's check the files that are generated. So this is some metadata. What this exif tool does is recursively collects the data metadata of each and every directory, and then it stores into this .txt file record files metadata, and we are opening it using the command open followed by recovered files metadata.txt. If you want, you can complete the whole process. It might take anywhere between 15 minutes to 45 minutes for completing the process. But I suggest to stop it after maybe like 3 to 4 minutes, so that some data is generated, some metadata is generated, and it's stored in this file, and you can open it and see it for this assignment. And the last command that we have is to test unallocated space, that is to see which spaces in the directory are empty. That is like whenever a file gets deleted, the storage or the space it is left unallocated, and sometimes some unwanted data might be present in some unallocated spaces. So we will be checking those unallocated spaces now. And we are using this particular command because it extracts readable text strings from unallocated disk spaces, and the offset is 2048. That is where our partitioning starts, and the sector partitioning, and this is the name of our data set or the file that we are using. So this is the first 100 sector strings that are there in the storage. This is all about assignment 3. Let us meet with assignment 4. Thank you.